Hi, welcome to Ekascloud. My name is Jagadish Mupati. Today I'm going to talk about routing table, and the gateway. What do they mean by that in the networking context? We already seen in our previous videos what is an IP address, what is IP address made up of, what are the different main classes of IP address, what would be the range of those different classes. For example, class A can go up to 127, and then the class B starts from 128, and then the class C starts from 192. These are all the different ranges which we have already learned in the previous sessions. We also looked at subnet mask, and also looked at IP address, which are made up of how the network bits are configured, how the host bits are configured. But today we are going to learn about the routing table, and then the gateway. What do you mean by the gateway IP address? To understand all of these things, probably we need to give a demo, a practical demo. That's what I thought, rather than by just displaying the definitions of each of those network components. It is better to probably do a practical demo. So for this purpose, I'm using a network simulator software called Cisco Packet Tracer. So basically, this is like simulation software, like flight simulator in real life modeling. So this network simulator, what it does is it can removes the headache of installing operating system, having a physical PC, and then try to configure the networks, and then you need to have multiple PCs. Whereas in this network simulator, we can able to virtualize all those in a diagrammatic fashion, and then we can able to know the meaning of routing table, and then the gateway address. Okay, so as you can see on my screen, I've just opened Cisco Packet Tracer, and here I can make a logical diagram of group of computer which belonging to a class A, class B, and class C, and we are going to connect them together and to see how the data packet travels from one place to another place. Okay, so for that we need a group of computers. Yeah, I'm going to create probably 2 PCs in each of the IP address class. So this is class A, this is class B, and then I'm going to create class C. So obviously all of these needs to be connected to a network switch. So we need a network component called a network switch. We're going to use 2960. Okay, so we have network switch, 3 of them connecting to individual network for class A and class B, class C. Now we need to connect them together to the switch. So we're going to use the network cable connection. So we're not configuring. All we are doing is we are connecting the network cable to the network switch, to all of these pieces. This is class B. This is class C set of computers. So what we have done is we have now, because anything like more than a computer is a network. So we have to make this demo much simpler. So I only included 2 pieces, but we can able to add as many pieces as we can possible. But for the demo purpose, I only included 2 pieces so that the configuration time will be a lot less. This is class A, and this is class B, and this is class C. So then now I'm going to configure the IP addresses for all of these things. So desk IP configuration. So we're going to start with 10. 1. So obviously that subnet mask will be 255.0.0.0. That means this is a class A IP address, and the network bits is only the first 8 bits. That means the 10 represents the network. So in this case, this is called network of 10. and the actual 10 networking ID is 10.0.0. Okay, so that's the one. So we're going to give this another IP address, which is the next IP address, which is 10.0.0.2. Same subnet mask, which represents the first 8 bits of the network bits, which is 255, and the remaining host bits are all set as 0.0.0.0. So that is the first class A. Okay, now this is the class B. So same thing I'm going to do, but in this case I'm going to set as 130.0.0.1. So obviously class B, the first 16 bits represent the network bits. So that's why the subnet mask indicates that, which is to the computer, that this is a class B IP address. And obviously it starts with 255.255.0.0. And then similarly, I'm going to set this IP address, which is the class B IP address. Obviously the subnet mask is the same as the first computer. Now I'm going to move into class C. So obviously the range will be different here. So I'm going to start with 192.0.0.1. So as you can see, the class C, the subnet mask is 24 bits. That is why it's the 255.255.255.0. So that is the first 3 octets. That is the 24 bits will represent the network part. Okay, so I'm going to make a class C as another IP address, which should be the 192.0.0.2. So corresponding subnet mask has been set here. So what we have achieved now, for example, if I go here, open a terminal, sorry, not the terminal. This is a command prompt. And then if I say ipconfig, so this is the class A network, and then clearly says the network is 10. And this is the 10.0.0.1, that is the first computer. So here, if I go and perform a ping command, so it is the loopback address. So that means I'm pinging myself to the same host. So if I ping 2, which is in the network as well, so I'm getting a reply. So if I try to ping the class B IP address, which is 130.0.0.1, obviously we are not going to get any response, because right now they are 2 different networks and they are not being connected at the moment. That is why we are not going to get any response back from them. That's why all the requests are going to get timed out. Similarly, we can try to ping class C as well, which is 192.0.0.1. So this will time out as well, because we have not connected class A to class B or class C. Okay, so they're all individual computer in its own sense. So we got each network, 2 computers connected to the network switch. So they're all network in their own sense, but they are not been connected to each other. So they're not been interconnected. So this is why we need a router. So router is nothing but a device which connects 2 or more networks into the router. So that is the router. And also it enables to transmit the data packets from one network to another network using the routing table. So that is why this demo we are going to understand what the concept of the routing. So for that we need a router. So this is the router, which I'll put it here to make sure that I'm going to connect to this router. So if I open this, the configuration. So as you can see here, I can see 4 fast Ethernet ports. Yeah, so first fast Ethernet ports. What this means is they are all the interfaces in the router. So the fast Ethernet port is in itself has got a, for example, if you click on that, so just got its own IP address and then the corresponding subnet mask. Similarly, we got fast Ethernet 1, which has got its own IP address and mask. Similarly, 4 and 5. So in this example, for this generic purpose router, we got 4 interfaces: fast Ethernet 0, 1, 3, 4, and 5. So how we are going to connect them to each other? Okay. So what we do, so for example, we'll start from 0. So make the connection first. Yeah. So obviously we have to connect from switch to the router. Yeah. Okay, so let's see. Okay, so that is fine. Okay, so in this case, so this has got only 1 and 2. As you can see, the 1 and 2 port, the switch has got only 1 and 2. So for the purpose of the demo, now we are going to connect from class A to class B. So as you can see, if you hover the mouse here, this is the first, the FA0, that is the fast Ethernet 0 port. And then if you hover the mouse, yeah, this is the FA1. So now we are going to configure this. For example, if we go on to this, so we go to FA0. So obviously FA0 is connected from class A network. So we're going to start from 10.0.0.100. So that is this is just an address to the interface, network interface, so that the class A network can able to connect to this. Okay, so we have given an IP address. So now this is class B. So this was started with obviously 130. Yeah, 130.0.1, and this is FA1. So again, we go to the configuration. So we set 130.0.0.100, and the corresponding subnet mask has been set here. So what do we need to do? All we have done is from network switch to network switch, that is class A and class B. For the purpose of demo, I've added a switch to, but there is a limitation on the number of interface it can able to connect. So I'm just keeping the demo now from class A and class B. So all we have done is we have connected 2 network switches to the router, and there is a class A set of computers and class B set of computers. But right now, this is still not a complete network, because all we have done is only made the physical connections. That means the network cable connection to the router. But of course, you can see all the red dot. That means it is still, the network is still switched off. Sorry, the router is still switched off. That means there is no connection at the moment. So if you try to ping a class A and class B IP address, it will be still coming as timed out. So what do we need to do? This is where we need to specify the gateway, because these computers needs to know if they want to send packets, the router needs to understand where this packet is destined to. So for that purpose, what we are going to do, we are going to set the gateway IP address. So gateway IP address is nothing but the IP address of the router. And we are going to set them on the individual let's close this IP configuration. As you can see here, we got a default gateway. So this is the one we are going to set as 10.0.0.100. That is the IP address of the fast Ethernet adapter network interface on the router. So I'm going to set that in the first computer on the class A network. I will do the similar one. And similarly here, I'm going to set the FA1. So the default one is I've set as 100. So I'm going to connect them here, which is the repeaters configuration. That is, sorry, 130.0.0.100. That is the default gateway. That is the IP address of the router in the interface level. So now we have made all those configuration in the individual PCs, and we also set the corresponding IP address on the router IP address as well. So as you can see here, if I hold the mouse, you can see those two IP address or network interfaces have been set 10.0.100 and then 130.0.100. And you can see the network bits as well. In the first one, it is /A because it's class A. And then in the second one is /16 because it's a class B one. So now all we are going to do is go to the config. We need to switch on the interface. So there is a on button here. That means it's going to be switched on. And the second interface, we want to switch it on. So as you can see, the red dots have turned into green. That means it's now ready to make the connection. So if I'm going to go back and open the command prompt, all this while, yeah, this request has been timed out. So now I'm going to do the ping from the class A network to class B network, which is from 10.0.1 to 130.0.1. So we are expecting to a proper reply from the other side, because we just now configured the network. It usually takes time, and the first one always gets times out. But if I ping the same IP address once again, I can see there is a response back clearly. So now that we have established and demonstrated that class A computer network can able to talk to class B computer network. So similarly, to show this, we can go from class B to class A as well. This is our class B network, and the first computer is 130.0.1. I'm going to ping from here to the class A network computer address, which is 10.0.1. We are expecting a reply, and we are getting a reply. So what we demonstrated is we have a set of computer which belong to class A IP address range, and then there is a set of computer which was belonging to class B IP address. So there are two different networks connected on the switch and the router. So we demonstrated how the data packets travel from one network to another network with the help of routing and the routing table, and obviously the gateway IP address, which we set it on the individual computer. Thanks for listening.